Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is question number 2.2 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's find the question. Calculate the total number of electrons present in 1 mole of methane. Second part is find the total number and the total mass of neutron in 7 mg of C14. Third part, find the total number and the total mass of proton in 34 mg of NH3. Now in the last, will the answer change if the temperature and pressure are changed? So friends, there are 3 parts. We will go one by one. First part is here. Calculate the total number of electrons present in 1 mole of methane. So friends, methane means CH4. Now, 1 molecule of methane is having, carbon is having 6 electrons, hydrogen is having 1 electron, but here 4 atoms of hydrogen. So we will multiply by 4 and we will get the answer 10 electrons. So in 1 molecule of methane we have 10 electrons. Now they are asking in 1 mole of methane how many electrons. So that 1 mole of methane, that is 6.022 into 10 to the power 23 molecules of methane contain 6.022 into 10 to the power 23 multiplied by 10, and the answer will be 6.022 into 10 to the power 24 electrons. This is the answer for the third part of the question. We have 6.022 into 10 to the power 24 electrons in 1 mole of methane. Now, this is very easy. Come up to the second part. Find total number and the total mass of neutron in 7 mg of C14. So friends, first of all, understand C14. C14 is an isotope of carbon having 14 is called the atomic mass and 6 is called the atomic number. So first of all, in C14, number of neutron is, so we are getting in 1 molecule of C14 number of neutron is A minus Z, that is 14 minus 6 is equal to 8 neutrons. In 1 molecule of C14 we have 8 neutrons. Similar we will do, so that in 1 mole of carbon 14, that is in 6.022 into 10 to the power 23 molecules of C14 contain, similarly as we did the first part, 6.022 into 10 to the power 23 multiplied by 10. Multiplied by 8. Now we have the 8 neutrons. We are talking about neutrons. So here our answer will be 48.176 into 10 to the power 23. And while making it more appropriate, we will shift the decimal 4.8176 into 10 to the power. Now here shifting decimal towards left, it means adding 1. So adding 1 to the power. So it will become 24. And these are the number of neutrons. So 1 mole in 1 mole of carbon 14, number of neutrons are 4.8176 into 10 to the power 24. Now one more thing, as we know that 1 mole is equal to molar mass. So 1 mole carbon C14 is equal to 14 grams of carbon 14. We can say we learned this in the mole concept. We are going to apply this concept. So if we can say 1 mole contains this much neutrons, or we can say 14 grams of carbon 14 contains 4.8176 into 10 to the power 24 neutrons. So if 14 grams contain this much, so we can say 1 gram of C14 contains 4.8176 multiplied into 10 to the power 24 divided by 14. Now, so that in 7 milligram we can write 7 into 10 to the power minus 3 grams of C14. Why? Because we are using grams, so 7 milligram we will change to the gram. In 7 grams, 4.8176 divided by 14 into 7 into 10 to the power minus 3. So after doing calculations, we will get the answer here, that is 2.4088 into 10 to the power 21, or we can write it like 2.4088 into 10 to the power 21 neutrons. So we can say in 7 milligram of carbon 14 we have 2.4088 into 10 to the power 21 neutrons. Now come up to the B part. They are talking about mass. So if mass of 1 neutron, that is fixed, it is 1.675 into 10 to the power minus 27 kg. So that the mass of 2.4088 into 10 to the power 21 neutron is, it should be directly multiplied, 1.675 into 10 to the power minus 27 multiplied by 2.4088 into 10 to the power 21, and after doing multiplication the answer that comes is 4.0347 into 10 to the power. So powers are always added, minus 21 plus minus 27 plus 21, it will become minus 6 and it is kg. This is the B part of the second question. This is the A part. Now in the similar way we will come up to the second part of the question, as we did the second part. Now we are on the third part of the question. Whatever we did in the second part, same we apply here. So here we have, in place of carbon 14 we have ammonia. Find the total number and the total mass. So first of all, ammonia, we will find number of protons in one molecule. 1 of ammonia contains, now nitrogen is having 7 electrons, so number of electrons are equal to number of protons present in any atom. So we will write 7 protons, plus hydrogen is having 1 electron, so 1 proton also, we will write 1 for proton into 3. It will become 10 protons. So one molecule contains 10 protons, so that 1 mole, or we can say, what is the molar mass of NH3? 1 mole NH3 is equal to, so nitrogen mass is 14, hydrogen mass is 1 into 3, it will become 17 grams. We can say 1 mole or 17 gram or 6.022 into 10 to the power 23 molecules of NH3. So 1 mole of NH3, or we can say 17 gram of NH3, or we can say 6.022 into 10 to the power 23 molecules of NH3 contains, now 6.022 into 10 to the power 23 multiplied by 10, and it will become 6.022 into 10 to the power 24 protons. So if 14 grams contains this much proton, so that 1 gram of NH3 will contain 6.022 into 10 to the power 24 divided by 14. So that now here they are asking in 34 milligram. 34 milligram, we will write 34 into 10 to the power minus 3 grams of NH3. It will contain 6.022 into 10 to the power 24 divided by 14 and multiplied by 34 into 10 to the power minus 3. What will happen? We'll multiply and we'll get the answer like this. In 34 into 10 to the power minus 3 gram of NH3. After multiplication, we will get the answer here. That is 12.044 into 10 to the power 21. So we can write it in more appropriate way. 1.2044 into 10 to the power. Now moving leftward means adding 1. So it is becoming 22 protons. So we have the answer. 34 milligram contains this much proton. Now the B part is here mass of the proton. So if mass of one proton, that is a fixed value, 1.6726 into 10 to the power minus 27 kg. So that mass of 1.2044 into 10 to the power 22 protons is equal to, directly we will multiply 1.6726 into 10 to the power minus 27 multiplied by 1.2044 into 10 to the power 22, and we will get the answer 2.0145 into 10 to the power. So minus 27 plus 22, we will get the answer minus 5, and that is the unit is kg. So this is the B part of our second part of the question. The mass of the proton will be 2.0145 into 10 to the power minus 5 kilogram. Now the last part of the question, that is what happen if the temperature is changed, it will affect or not. The answer is no. There will be no effect of change in temperature and pressure on these mass and the number of molecules. So friends, that's all for today in this video. The question is a bit lengthy, but the calculation is very simple. Simply we put the mole concept and we applied the unitary method. That's all for today in this video. Please like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.